In Lesson 3.5, we will be modeling functions with nonlinear regression. In Video 3.5.2, our learning target will be for students to model data with exponential, logarithmic, and logistic functions. In Example 2, we will be using logarithmic regression to model a group of students studying a photograph for 30 seconds. Beginning 1 day later, a test was given each day to test their memory of the photograph. The average score for each day is shown in the table. Use logarithmic regression to model the data, then use your model to predict the average test score after 2 weeks. So we're asked in this question to use logarithmic regression. So we know that this data is approximately logarithmic or models a logarithmic equation. We have two variables, days and score. X is the number of days, Y is the score, which is the percentage of the photograph that they remember after X days. You can see that the percentage goes down, that over time, or over the number of days, the percentage of memory that they have about the photograph is decreasing. So what we're going to do is start by entering our data into our lists. In Video 1, I talked about how you enter data into your lists. So go ahead and go to your lists under Stat and Edit and enter X into List 1 and the score into List 2. Once you've entered your data into your list, we next need to turn on our stat plot. If you've just watched Video 1, it's most likely that your stat plot is turned on from the previous example. So if you go to stat plot, just double check to make sure that your stat plot is turned on. And if you press stat plot right here by pressing second and then Y equals, that will go to your stat plot, press enter on plot 1, make sure your plot is turned on and that your lists where you've entered your data are list 1 and list 2. The next thing we need to do before we graph our scatter plot is to change our window, which window is right here next to Y equals. And if we change our window, we need to let X represent the number of days. So in this example, I'm going to say let X minimum equal 0 and X maximum represent 10. I think the data went from 1 to 7, but this window right here gives us some extra wiggle room to the left and to the right of our data set. Our X scale, if we're going from 0 to 10, 1 is an appropriate number or scale. We can count by ones going from 0 to 10. Y minimum and Y maximum, which represents the percent of the information from the photograph that was remembered or recalled. And based on our table or data, our percentages range somewhere between 50 and 75. So I'm going to say my minimum is 50% and the maximum was 75%. I think the actual maximum was like 72 or 73%. But again, just like I did on the X window, I'm giving ourselves some extra room on either side of the actual data set. So if I'm going from 50 to 75, I think 5 is an appropriate scale. And once you have your window changed, you can go ahead and press graph right here, and you should see your scatter plot. Now here is on this slide the scatter plot that the book got. They chose an X scale the same as ours. They went from 0 to 10 counting by ones. Their Y values, Y minimum and Y maximum are the same as ours, but notice they used a scale of 0.5, which is 0.5%, and we went up by 5s. So their graph is going to look slightly different than ours, but it'll look pretty similar. So what we want here is to let S of t represent the student's average and this average score, and t represent the days after studying the photograph. So the x-axis would be labeled with time or number of days. The y-axis would be labeled with the percentage or the percent of the photograph that they remembered after t days. Once we have our scatter plot created, our next step is to come up with a logarithmic regression. And in order to do that, we need to go to Stat. So we're going to press the Stat button again. That's the same button we pressed to enter our data. Stat was right there on the calculator. And then once we get to Stat, instead of choosing Edit this time, we're going to choose Calculate, which is, you have to use your right arrow here to move over to Calculate. And in step 3, we're going to go ahead and calculate our regression. So under the Calc menu, there's a bunch of different types of regression. We are going to choose Natural Log Regression, LNReg. Natural Log Regression is option number 9 under the Calc menu. And depending on the operating system, you're going to have two different things that could occur. On the old operating system, which I have, it's going to bring me back to the main screen and say linreg. And then I need to tell the calculator what two lists I need it to calculate a linear regression for. So at this point, I'm going to do L1, L2, and then press Enter. Now, L1 and L2 are right here in blue above the 1 and 2 keys. So you have to use the second key in order to input L1 and L2. And the comma is right here above the 7. Then I can press Enter and it gives me my linear regression equation. Now, from there, it's going to give me my actual equation. Those of you that have the newer operating system, just make sure that when you get to the linear regression screen, you make sure that your lists are L1 and L2, and then you can just go down to Calculate. There's a little screen at the bottom or word at the bottom that says Calculate, and select that by pressing the Enter key, and it'll give you your equation. So we're going to calculate our equation. Now, once I do that, my screen should give me the following equation. The general equation for a logarithmic regression is a plus b ln of x. So I need to substitute the values of a and b, which in this case, a, if I round, is 73.1, and b should be a negative 7.31 or 7.3 natural log x. Since I have a plus and a negative sign right next to each other, I could just say 73.1 minus 7.3 natural log x as my equation. As you can see, the book got the same equation as we did. The correlation coefficient, if you have your diagnostic turned on, is R equals negative 0.9835, which means that we have a pretty good fit here. The negative means that the only reason R is negative is because, remember, our percentages were decreasing. This function is a decreasing function because as time, or x, increases, y is decreasing, which would give us a negative R value. It's a decreasing function. So the correlation is negative because as one variable increases, the other variable is decreasing. It is a close fit because R, if we discussed R, it's close to -1, which means we would have R value of -1 would mean we had a perfect fit. 98% is still pretty good. And the equation they got was the exact same as what we had. Their A value is 73.1 and their B value was -7.31. The next step, I would like you to copy and paste your regression equation. So to paste your regression equation into y equals, or into our equation editor, we're first going to select y equals, which is right there. And once we go there, we're going to press vars Make sure under y equals that you delete anything in y1. Select y equals, and then we want y1. So place your cursor in y1 here, and make sure there's no other equations in there. From there, we're going to go to vars. Go to the vars button, which is right here. And then under the vars menu, we're going to go to statistics, which is option 5. Right. Under the vars menu, we'll press statistics, which was option number 5. And from there, after we choose statistics, I want you to arrow over at the top. There's an EQ. We're going to arrow to the right to get there. So once you go to the EQ menu, or equation menu, we're going to select number 1, which is regression equation. Okay, so once we do that, you should see your equation, your logarithmic regression, copied and pasted into y equals or y1. At this point, you can go ahead and press graph after you have your equation in y1. Once you press graph, you should see something similar to what we have on this slide. Again, because the book used a different window than we did, or actually they used the same window, but they used a different scale on the y-axis. You should see something similar to them, and you can see that the reason why we got an R value that was negative 0.98 was that this logarithmic equation right here, this curve, excuse me, I can't get it exactly on the screen, but that curve is a pretty good tight fit to the dots on our scatter plot. So that is why we got such a great R value or correlation coefficient, was because the logarithmic function goes through almost all the points, or the ones that it doesn't go through, it's very close to. Our last step in this problem is to go ahead and calculate a value. The question asked us what percent the student, what percent of the photograph the student would remember after 2 weeks. Now remember, X is measured in days. X is in days. So 2 weeks of time would really mean X equals 14, because there's 14 days in 2 weeks. So here's the thing. Before we go ahead and calculate our value, we could go, we have to go ahead and change our window, because remember, our window, we only set to go from X equals 0 to X equals 10, and 14 is outside of that window. So I need to go to my window here and change my X value to something larger than 14. So I'm going to go ahead and switch our X maximum now to 15. If I switch this X maximum to 15 and change my window to go from X equals 0 to X equals 15, counting up by ones, then I can go to the calculate menu, which is up here underneath trace is the calculate menu, and then we can choose option number 1, which says value. Once I select value by pressing enter, that's going to bring me back to my graph, and there should be a blinking cursor that says X equals. And then it's just got this blinking cursor on your graph. At that point, I can type in 14 and enter, and it'll tell me Y equals 53.8%. What this means is that after 2 weeks, the student will remember approximately 53.8% of the photograph. So looking at what the book did, you can see that when you calculate the value, your cursor's right down here towards the bottom of the screen. They also changed their window to go up to 15. And here's our model or equation, our log model or equation. Actually, we should have had a natural, oh, they do have it, natural log of t right here. And then our prediction based on time equaling 14 days was that our knowledge or memory would be 53.8%. In example 2, again, we'll be working with memory. In this example, students do not remember everything presented to them in a mathematics class. The table below shows the average percentage of information retained T days after the lesson by a group of students. Use a logarithmic regression model to predict the student's retention percentage on the 10th day. In this table, you're given days and the percentage retained. So 1 day after the lesson, students would remember 56.2% of the lesson. In day 2 or 2 days after the lesson was presented, you would expect students to represent 52.3 or retain 52.3% of the information presented. As you can see, the percentage is decreasing, and you're asked to find a logarithmic regression to model this set of data. What I would like you to do is calculate your logarithmic regression model and also then use that model to predict the percentage of student retention on the 10th day. You have 4 choices, A, B, C, and D. Select your answer and then press submit.